All right, so we are looking at polynomial functions, part 2. So in order to do that, we are going to still classify them, but now we are going to put them in standard form. So in order to classify them and put them in standard form, we also need to talk about what makes a polynomial a polynomial. So those are today's goals. So, non-examples of polynomials include fractions and division, where the base is a variable, because remember, we can have the base being a number. Square roots are not polynomials. Variables in the exponent, so right here, that exponent has a variable. And when the variable has a negative exponent, because what that would do is drop the variable down to the denominator, bringing it right back into the category where it has division of a variable. These are not polynomials. The terms of a polynomial can be written in any order. However, if they are written or to be written in standard form, then the standard form of a polynomial is when there is one variable and the terms are written where you start with the greatest degree of that single variable and you go to the smallest degree. When written in standard form, the leading coefficient is the value of that first term. So let's look at some examples. Writing polynomials in standard form. So you have 6x minus 7x to the fifth plus 4x squared plus 9. What we want to do is find the degree of each term. So the degree of the first term here is 1. The degree of the next term is 5. The degree of the next term is 2. And the degree of 9 is 0. What we're going to do is now order them from largest to smallest. So 5 is our largest, then 2, then 1, then 0. So that's the order that we've put them in over there. After they're in order from greatest to least, this is called standard form. And then again, the leading coefficient is the number on that first term in standard form. So in this case, the leading coefficient is -7. So once again, we have an example, y squared plus y to the 6th minus 3y. We are going to rearrange our terms so that they are in order from greatest to least in terms of degree. So that's y to the 6th plus y squared minus 3y. And the leading coefficient is the value on that first term, which in this case is 1. Example C, we have 16 minus 4x squared plus x to the 5th plus 9x cubed. So now I have a few extra goals. We want to put it in standard form. We want to give the leading coefficient, and we're going to name it. Standard form is x to the 5th plus 9x cubed minus 4x squared plus 16. The leading coefficient is 1. And there are 4 terms, so it's a polynomial. And the highest term is 5, so it is quintic. So we have a quintic polynomial. 18y to the 5th minus 3y to the 8th plus 14y. Standard form is -3y to the 8th plus 18y to the 5th plus 14y. The leading coefficient is -3. And this would be classified as an 8th degree trinomial, coming from the fact that there are 3 terms and the power of the highest term is 8. your turn. At the end of this assignment, there is a link to a form in Teams, and these questions will be there for you to answer.